excuse me. Yesterday we talked about factoring perfect cubes. Today we need to talk about factoring by grouping. Okay, we need to talk about factoring by grouping. It's a different type of factoring. Here's what we need to look for. We haven't factored anything yet that has 4 terms. So a tip-off that it's grouping is that it has 4 terms and your highest exponent is 3. We're going to set up 2 sets of parentheses here, but we've got a little bit of extra stuff going on. We've got a spot in front of both sets of parentheses because what we're going to do is we're going to pair our terms up, and we're going to find the GCF of the first pair. We're going to find the GCF of the second pair. Those GCFs are most likely not going to be the same. But what is going to be the same, after we factor out those individual GCFs, then what's left after we factor out, we should have the exact same expression. We should have the exact same expression inside both sets of parentheses. If you do not have the exact same expression inside both sets of parentheses, it's not factoring by grouping, okay? You've either done something wrong or it just can't be factored by grouping, all right? That's the key right there. And then we'll look at how we simplify it from there. And of course, anytime we factor, we can multiply it back out to check our factor. All right, so let's look at this first example. Example number 3, part A, 15x cubed plus 18x squared plus 20x plus 24. So we always look for a GCF in general, but throughout this entire problem, there's no GCF, okay? 3 out of the 4 terms have an x, but all of them have to have an x. 15, 18, 20, and 24 don't have a common factor. So it has 4 terms, the highest exponent is cubed, so that means we can probably factor it by grouping. So we're going to pair the first 2 terms together, and we're going to pair the second 2 terms together, or excuse me, the last 2 terms together. So looking at the first pair, what is the GCF for 15x cubed and 18x squared? 3, what else? X squared, okay? Don't forget the x squared part. All right, so when we factor out 3x squared, what are we left with? 5x, because 15 divided by 3 is 5. X cubed divided by x is x, or excuse me, x cubed divided by x squared is x. 18 divided by 3 is positive 6, and the x squared, we pulled that out. Okay, what about in the second set of parentheses? What's our, or not parentheses, second pair, what's our GCF there? 4. So we're going to put a plus 4, and we're going to factor it out. 20 divided by 4 is 5. It had an x. 24 divided by 4 is 6. Notice, this linear factor, okay, that's linear, 5x plus 6, that's linear. It is the exact same thing, okay? So we need to look at this like, okay, here's a term, here's a term. Okay, terms are always separated by pluses and minuses. So look at that entire first thing as a term, the second thing as a term. What do they have in common? They both have 5x plus 6, right? So we can take out the 5x plus 6 because they both have it in common, and we are left with 3x squared plus 4. Okay, they both had 5x plus 6 in common, so we factor that out as a GCF, so to speak, and we're left with the 3x squared plus 4. Now, remember, I said, multiply it out. Make sure. 5x times 3x squared, 15x cubed. 5x times 4 plus 20x. 6 times 3x squared plus 18x squared. 6 times 4 plus 24. It's not in the same order, but we've got all the same terms. So that is the factored form. Okay? So, not that hard, it's just different from anything we've done. Let's do another one. example B, 56n cubed plus 24n squared minus 35n minus 15. 4 terms, highest exponent's 3, so let's pair them up. 56 and 24, what should we take out? 8n squared, very good. All right, 56 divided by 8, 7n. 24 divided by 8, 3. The n squared, we took out the n squared. Okay, negative 35 and negative 15, what do we need to take out? Negative 5. Whenever that leading term is negative, you got to pull out the negative, okay? Or you're not going to get the same signs inside your parentheses. Negative 35 divided by negative 5 is positive 7n. Negative 15 divided by negative 5 is positive 3. Now, please don't jump to the conclusion that you get the exact same term. You need to actually make sure that you do, in fact, get the same linear factor when you factor those out. Okay, so we have 7n plus 3 in common. When we factor that out, we're left with 8n squared minus 5. Now, I'm not going to go through the process of checking this one. I just wanted to check the first one to show you how that whole process actually worked. Okay, but you can always check it. Okay, I would rather you check it. I'm just not going to take the time to do it myself. Okay, let's do 2 more, and then I'll let y'all work on these. 9n cubed plus 12n squared minus 15n minus 20. Okay, pair them together. 9 and 12, take out a 3, n cubed and n squared, take out an n squared. 9 divided by 3 is 3. N cubed divided by n squared is n. 12n squared divided by 3n squared is plus 4. Alrighty, negative 15n minus 20. Negative 5. Factor that out, we're left with 3n plus 4. So 3n plus 4 is our common factor. We are left with 3n squared minus 5. Okay, one more. D, 2x cubed and 9x squared. What can we take out of those? 2x cubed and 9x squared. What can we factor out there? Just an x squared, okay? Now, it doesn't happen a lot, but there are some occurrences where there's no numeric GCF. It's just the variable. So we're left with 2x plus 9. All right, what do we need to take out of the second pair? Negative 4. That leaves us with 2x plus 9 as well. So we've got 2x plus 9, and we've got x squared minus 4. Is there anything else we can do this problem? We're talking about factoring. Can we factor 2x plus 9 anymore? 2x plus 9. Does it factor further? It's not a trick question. No. Okay. How about x squared minus 4? Can we factor that? Yes. It's the difference of perfect squares. Okay, you can't forget that quadratic factoring stuff just because we moved on to polynomials. Okay, so we didn't deal with that in any of the previous problems. We did not have the difference of perfect squares. 3n squared minus 5 is not a perfect square. I can't remember what the other ones were. 8n squared minus 5, not the difference of perfect squares. 3x squared plus 4, definitely not the difference of perfect squares. But sometimes we do run into a few that will factor further. So once you finish your grouping, you do need to take a second and check and see, can this factor further? Do I have the difference of perfect squares? That's really the only thing you're going to have to look for is the difference of perfect squares. Okay, you're going to have to look for the difference of perfect squares. So that's grouping. Okay, that's factoring by grouping. So what I want you to do is I want you to just finish out the worksheet. Okay, do them all.